Hello students, welcome to Unit 3 Notes, Section 9.2. At this time you can pause the warm-up and try it to save time. In the interest of time, I'm going to start it. So, write an equation for a line through point A that is perpendicular to the given line. So here we have x equals -2, and we have point A. So what I'm going to do is I'm going to draw what appears to be a perpendicular line. And it's going to go right through point A. And the question is, what is that line? And that line is, let me put arrows on it. That line is y equals -2. And the reason is because y equals -2 is a horizontal line that has a slope of 0, where it is perpendicular to a vertical line that has an undefined slope, where x equals -2 is just the location where it goes through the x-axis. In this case, this is the y, and it's going through the y-axis. This next one, because we're given y equals, we'll now have x equals, and that one is going to be going like this through here, and that is x equals -1. Again, it goes right through this point of -1, where this last one went through the point -2. And this last one, okay, this one's a little bit more difficult. We're going to go on a diagonal here, and I believe that it is perfectly perpendicular like that. And I'm just going to move it up like there. And yep, that looks pretty good. And this is going to be y equals -x. And the only thing is that to go through that point, I had to go up a little bit. So my y equals mx plus b, my slope-intercept form, I definitely have a slope of -1x, but it also goes through the y-coordinate of 1, the y-axis coordinate of 1, so it has a little bit of a vertical shift here for it to go through the point -1, 2. So those are the equations of the lines that are perpendicular. So why are we doing that? Well, it has to do with reflections, and we'll talk about it today, but reflections is the next lesson, and that's our only vocab. And we're going to find reflections of images and figures. Remember, reflections are rigid motion, so they are rigid motions. Rigid motion isometries. And the reason being is because they do not change in size or shape. So they do not change size or shape. And what shape means is that the angle measures stay the same. Size means that the side lengths stay the same. Okay, so here a reflection. Here's our first example. Well, this is just our explanation of it. So a reflection or flip is an isometry in which a figure and its image have opposite orientations. So what that means is, here you have UGB. UGB, as I read around it, UGB is going in what's called a clockwise motion. And here UGB prime, so U prime, G prime, B prime, is going in the reverse order. That's how I know that these are reflections. Take a look at this real world example. Look at ambulance. Ambulance is backwards. It's written backwards. You know why? When you look in your rearview mirror and you read it, it will actually look like it's spelled correctly, ambulance, because it's a reflection and it changes that order. So UGB now looks like U prime, G prime, B prime. Okay. Now, it's an isometry that has opposite orientation. Thus, a reflected image in a mirror appears backwards. In the diagram below, triangle BUG is reflected across a line to produce B prime, U prime, G prime. These are both triangles. Since the reflection is an isometry, triangle BUG is congruent to triangle B prime, U prime, G prime. All right. Even on Google Meet, when we're meeting on Google Meet, when I look to the left, it looks to me like I'm looking to the left, but I'm actually, well, when I look to the left, it to me looks like I'm looking to the, when I look to the left, it looks like I'm looking to the right if I was looking at myself in a mirror, or if I was looking at myself, it looks like I'm looking to the right, but on your screens, it looks like I'm looking to the left because it's actually doing what I'm doing in person, but it's showing a reflection of it. All right, so you can use the following two rules to reflect a figure across a line. That's why we were talking about perpendicular, because take a look at this. Here's my line of reflection, and here is a perpendicular line to that line of reflection. And why does that matter? Well, B is going to be perpendicular to this line of reflection, and B prime will also be perpendicular to that line of reflection, and they're going to be equidistant from that line of reflection. What does that mean? Well, if this is 6 units away, then B prime is also 6 units. And if C is 5 units, then C prime will be 5 units as well. Whoops. So C. So if that is congruent to that's going to be congruent to that, and that might be 5. I don't really know. I'm just making this up. Well, let's just say 5.5. Then that one's 5.5. And these are also perpendicular, okay? A didn't move because A is on the line of reflection, so A now becomes A prime. So what you're going to do is you're going to count from the line of reflection perpendicular to the line of reflection, and then count the same amount of numbers continuing on when you actually perform a reflection. So if point A is on the line, then the image of A is A itself, therefore A prime is equivalent to A. If point B is not on the line, so B or C are not on the line, then R is the perpendicular bisector of B prime. So this line segment B prime is literally in the middle of it. And that's all it's saying. So we're going to reflect right across the line. You have equivalent distances. And yeah, that's it. So as the diagram shows, a point on the line of reflection is mapped onto itself. Otherwise, a point and its image are equidistant from the line of reflection. So let's do our first example. Our first example says finding a reflection image. Here's a point 2, 1. It says given this point, if it's reflected across the line y equals 1, then what are the coordinates of its reflection image? So let's graph the line y equals 1, and that looks like this. Here's the line y equals 1, and there's the line y equals 1, right? Yeah, this is 1. The point is at 2, negative 1. Oh, I put it in the wrong spot. Whoops, I put it in the wrong spot. That's all right. I'll fix the notes for next time. Here's a line. Here's a point P of 2, negative 1. I was wondering why it was on the line. I must have been thinking ahead. I don't know. Okay, so there's 2, negative 1. So let's reflect this across the coordinates of y equals 1. So here we go. Ready? Watch this. 1, 2, 3, 4. So when you reflect it to get P prime, you have to reflect it across. So we're going to count 1, 2, 1, 2. What I'm doing is I'm creating this perpendicularism here. So here's the line y equals 1. And here is, well, here is the incorrect coordinate. And what we have is you have P, which is at 2, -1, going 1, 2 to get to the line, and 1, 2 more to be a reflection. So this point is at 3, comma, nope, sorry, I'm messing everything up here today. 2, comma, 3. 2, comma, 3. So 1, 2, 1, 2, 3. It's 2, comma, 3 from the origin, where this other one was 2, comma, -1 from the origin. So that is actually my answer. And there we go. That's the image of the reflection. That's a reflection image, right? So what are the coordinates of the image of P if the reflection line is the x-axis? So let me move this down a little bit. Let me move this line down. Whoops. And let me do a reflection across the line, across the x-axis. So here's the x-axis. I'm just going to move this down. And instead of being there, it's actually where this other point is. So that's a reflection across the x-axis. You know what? That's probably the question I was trying to answer when I made it. So here's P prime, which is at 2, comma 1. So here's 2, comma 1. P prime is at 2, comma 1. Okay. Now, what are the coordinates of the if I reflect it across the y-axis? Okay, so let me erase that. Let me mark up this point. You know what? Let me use white. Let me try to get rid of it. Okay. So now what do we got going on? We're going to reflect across the y-axis. So here we have the y-axis, and let's reflect it across. So 1, 2, 1, 2. That's where it ends up. And that location is 2, comma, -1. Nope, sorry. Oh my God, I'm messing everything up today. -2, comma, -1. So the answer to P prime is -2, comma, -1. All right. What are the coordinates of the image if P is reflected across the line, image of P, if the reflection line is y = 0? Well, y = 0 is right here. Y = 0. Wait a minute, that was the x-axis. We already had that point. It was right here. So P prime was at 2, comma, 1. So this is P prime. P prime is at 2, comma, 1. And what about if we do the line x = 0? Wait a minute, that's the y-axis. So that is the same thing as this one, okay, which is P prime is -2, comma, -1. So what are the coordinates of P? So what can we conclude? We can conclude that the x-axis is the same thing as y = 0, and that the y-axis is the same as x = 0. And so in return, y = 0 is the same as the x-axis. They have the same answer. And x = 0 is the same thing as a y-axis. So whether you see y = 0, x = 0, y-axis or x-axis, they're both talking about the same thing. Okay? All right. So what are the coordinates of the images of P if the reflection line is x equals 1? Well, in this case, we're just going to do x equals 1. Is it 1? Yeah, that's what I have. So we're going to do that. And we are going to just do it quickly over the over here, and it will end up right there. And so P prime is 0, whoops, 0 comma negative 1. And that's it. P prime is at 0 comma negative 1. All right, just a whole bunch of flipping. All right, so I'll leave that blank so that because we wrote all over it really. I don't want to leave it confusing in the notes, but that is what we have. So we got a little bit more to do here. Okay, each point is reflected across the line indicated. Find the coordinates of the image. So C is reflected across the x-axis. That would put C prime. That would make C prime. Let's see. Reflects across the x-axis. So 1, whoops. So x-axis is 1, 2, 1, 2. It puts it right there, which is at negative 3, negative 2. And that's it. And now H is across the y-axis. So H is across the y-axis. So 1, 2, 1, 2. So it puts me at negative 2, negative 3. So H prime is at negative 2, negative 3. Yep, and that's it. So I'm just counting. I'm just doing the mirror and reflecting it. Okay, so I'm counting to the line and then past the line. So E across line y equals negative 1. So here's y equals negative 1. And so now E is right here. So E is 1, 2, 3, 1, 2, 3. So that's E, which looks like it's negative 1 comma negative 4. Negative 1 comma negative 4. All right, F across x equals 1. F across x equals 1. X is a vertical line, so we have to be careful. Is it x equals 1? Yeah, F across x equals 1. Here's x equals 1. And so we're going to go 1, 2, 3, 1, 2, 3. It's going to put it right there, which is at 4 comma negative 2. So 4 comma negative 2. All right, G across x equals 3. So G across x equals 3. X equals 3 is right here. Right? That's x equals 3. Yep. Okay, so it's 1 and 1. So it's going to be at 4 comma negative 1. All right, and I prime, oops, I messed this all up. 4 comma negative 1. Let's try that again. The next one is I prime, which is at something. Okay, this is at negative 1/2. And negative 1/2, that's a tough one. So negative 1/2 is right here. It's y equals negative 1/2. That line's going to be right there. Okay. And why are these the same color? Give me one sec. That belongs to be blue. That should be green. Okay. So, whoops. I is going to be 1, 2, 3.5 away. So I have to go half, 1, 2, 3. So I'm going 3.5 and then 3.5 again. So I'm going a total of 7. All right, and that's going to be I prime, which is going to be at 3 comma negative 4. All right, and that slide is over. The next one, we're going to, this is going to take a while, but we'll get through it. Given the points A, B, and C, which I think I graphed them correctly, draw ABC and its reflection image across the line. Well, I already did that for all of these. I wanted to save some time for us, so I went through and I made sure that they were all drawn. But we're just going to reflect this across the line that is given. So here it's the x-axis, okay? So I'm going to reflect B. It's 1 and 1, so B is going to go there. C is 1, 2, 3, 1, 2, 3. C is going to go there. And A is 1, 2, 3, 4. So it's going to go 1, 2, 3, 4. And that's going to be A prime. A prime, B prime, C prime. And I'm going to just erase that because we don't want to leave that there. I'm just showing you for note's sake that that's what we're doing. Okay. That goes, whoa, that's supposed to be a edge. All right, so there you go. There's A prime, B prime, C prime. All right. This next one is across the y-axis. So we're going to do this, the y-axis. And we are going to, oh, this is cool. Watch this. Anything on the left-hand side is going to end up on the right-hand side. Anything on the right-hand side will end up on the left-hand side. And anything in the middle stuck on there will stay stuck on there. So this next one is going to be A, 1, 2, 3, 1, 2, 3. Goes right there. So that's A prime. And then we're going to do C prime. 1, 2, 1, 2. Okay. And B is stuck where it is, so that's just, so here's our C prime. And then here's our B prime. It's stuck. It's okay. And then here's our next triangle. And that is it. It's overlapping. It kind of looks like a, kind of looks like an airplane or something. Okay, like a futuristic jet, stealth jet. All right, there we go. So this next one, across y equals 1. So here's y equals 1. Look at, whoops. So B is going to, we'll go backwards. That's weird. So here is, there we go. This is y equals 1. And in this case, everything is going to stay exactly where it is. I'm sorry, for B, it's going to stay exactly where it is. And for everything else, we are going to go down what we need to. So 1, 2, 1, 2. So that's C prime. And then A is 1, 2, 3. So it's 1, 2, 3. So A prime is right there. It's A prime. And I'm just going to connect A, B, and C, which is pretty cool. And there you go. Again, this is B prime, so I'll just write B. I don't know where to put it. B prime. Okay. All right. There's a couple more. So here we are. So y equals 3. So y equals 3. Let's see. I'm going to do y equals 3 up here. 1, 2, y equals 3. Okay. And I'm going to leave c where it is. A is going to go down 1 and down 1. So there we go. A is all good. B is going to go up 2. So it's going to go up 2. So that's b prime. There's a prime. And then c prime stays exactly where it is. And we connect. I don't know why it's doing that. It won't go back when I create a line. Okay, and that's it. Oh, it really is not liking my smart notation. Hold on. Okay, let's see. Let's try that again. Oh, moved me around. It did not like it. Let's see if it likes it now. Much better. Oh, still not good enough. There we go. And that's your reflection. C stayed where it was, B moved up 2 and up 2, and A moved down 1 and down 1. Okay, now this one is tough. This is going to be the line y equals x, and I'll show you what we do for this. So here's the line y equals x, all right, and it's linear, right? So here's y equals x, here's the line y equals x, and that's because it has a slope of 1 and a y-intercept of 0. And so now all I want to do is count diagonally and make it perpendicular. So see how C is 1/2 a diagonal unit away? Let's take a look. It's half a diagonal unit. It's right there. So we have to go another half of a diagonal unit, putting C prime right there. So C prime is going to go right to there. And now B is going to do the same thing. It's 1/2 a unit diagonal. So it's B prime. And then here's C prime. And now A is a little bit different. A is 1 diagonal unit, 2 diagonal units, 3 diagonal units, 3.5 diagonal units. So it has to go another half and then 1, 2, 3 diagonal units. And that, folks, is how the perpendicular is working. Like I told you, we should be working and doing. That diagonal gets us there. Okay? And this is A prime. And so what I just did was I just made a reflection across the line y equals x, which was actually pretty easy to do once I am getting more comfortable with this and the hang of it. So there's your A prime, B prime, C prime. And now this last one is a reflection across the line y equals negative x. So in this case, it's similar to what we just did. Except we're going to move that up right there. Boom. So this is the line y equals negative x as a slope of -1 and a y-intercept of 0. All right, and I'm going to count diagonal this way. So here is 1/2 a diagonal and 1/2 a diagonal. So that's going to go there. This is 1/2 a diagonal and half a diagonal, so it's going to go there. And the last one is a little bit tricky. It's 1, 2, 2.5 diagonal. So it's 1/2, 1, 2 diagonal. So it's 2.5 diagonal. And there we are. And so this one is A prime. This one is B prime. And this is C prime. And that explains that about counting. Okay? But let's take a look real quick. Look at this 2, 3. Here, C was 2 comma 3, and C prime is, let's see, C prime is what? C prime is negative 3 comma negative 2. Okay. It looks like, what happened? How did I get from C to C prime, and C prime being and looking so much different than C? Well, here's what happens. Wherever I see an X, I put in an opposite value and put it in the Y place. And wherever I see Y, if I were to find the opposite value and put it in the X place, then I get the change by making those opposite and flipping their locations. Why? Because when Y is equal to opposite X, then X is equal to opposite Y, meaning that if I have a 2, that's an X, I now have a negative 2 as my Y, and vice versa. So if I have 3 as my Y, then I have negative 3 as my X. Because what I've done is I have switched wherever I see a Y and I put in an opposite X. Wherever I see an X, I put in an opposite Y. And that brings us to our last slide, which is the summary of our reflection rules. So you have to memorize them because they're special cases, but only a couple of them. For anything that is not a special case, just count, like we did. The preimage and image locations must be equidistant from the line of reflection. So here we have reflection across x-axis and the line y equals over. They're the same thing. What happens? Well, when I flip across the x-axis, what we notice is that our x's stay the same, that only the y's become opposite. Okay? So let's put a little note here. That means opposite, not negative. You're not going to force something to be negative if it already was negative. You're just going to make it positive now because you're going to apply that opposite to it. So opposite y, let's take a look. When I flip something over the x-axis, it changed my y's, right? 2, 3 became 2 comma negative 3. It only changed my y's, but my x's stayed the same. My y's became opposite of what they were. In this case, 3 becomes negative 3. And then for a flip across the y-axis, that same thing happens, but backwards. So here we have negative 3 comma 4, and here we have 3 comma 4. Well, what's happening? They're staying exactly where they are, but the x value is becoming opposite. And so when we're done with all this, when we look at it all, we see that the x-axis and the line y equals 0. The x's stay the same, but the y's become opposite, and they stay exactly where they were. So here's another example. 2 comma negative 6 would then turn into 2 comma 6. And the reason being is because they are staying where they are because it's only a reflection across the x-axis. So all that's changing is my y. They are becoming opposite. So negative 6 becomes opposite to 6. All right. And then the next one is a reflection across the y-axis. So similarly, but the y stays the same now instead of being opposite, but the x becomes opposite. So here, you're going to leave it exactly the way it is, and you're going to say, well, this is going to be negative 3 because this is going here and becoming opposite. Okay, oops, I messed up. I'm thinking ahead. Sorry. Nope, it is negative 5 stays where it is, but it becomes opposite. So negative 5 becomes a positive 5, 5 comma 3. All right. This next one is switching the x's and y's wherever you see them, because a reflection across the line y equals x is when we switch x's and y's. So wherever I see an x, I put a y, and wherever I put a y, I see an x. And so here you have 2 comma negative 1, which will become which will become instead flip them. So it will become -1, comma 2. Because all I'm doing is putting a y where I see an x and putting an x where I see a y. So 2 comma -1 becomes 1 comma 2. And then just think that, sorry, so yeah, this 2 comma 3, or this -3 comma 4 now becomes 4 comma -3. All you're doing is switching those values, and that is true. It matches up. See, this -3 comma 4 and this 4 comma -3. 4 comma -3. So all we're doing is switching, where in this one we switch and we flip. So this last one, you're going to flip and switch. So 4 becomes -4, and -8 becomes a +8. And those are our rules, okay? And that's it. So you need to memorize these rules. Just remember, negative doesn't mean negative, it means opposite. So you're going to find out whatever is opposite to it. And you can start the exercises for notes 9 too. All right, good luck.